मित्रांनो, नमस्कार. मागच्या लेक्चरमध्ये आपण रोल्स थिअरम वरील आधारित असणारे प्रॉब्लेम्स पाहिले. रोल्स थिअरम आणि लॅग्रेंजेस मीन व्हॅल्यू थिअरम असे दोन ॲप्लिकेशन्स, हे ॲप्लिकेशन्स ऑफ डेरिव्हेटिव्हज या चॅप्टरमध्ये आहेत. आजच्या व्हिडिओमध्ये आपण रोल्स थिअरमचे काही व लॅग्रेंजेस मीन व्हॅल्यू थिअरमचे काही एक्झाम्पल्स पाहणार आहोत. एक गोष्ट पक्की लक्षात ठेवली पाहिजे, ती म्हणजे सीईटीच्या परीक्षेसाठी तुम्हाला डिटेल्ड सोल्युशन्स करण्याची आवश्यकता नसते. रोल्स थिअरम किंवा लॅग्रेंजेस थिअरम सॅटिस्फाय होतो किंवा होल्ड होतो असं ज्यावेळेस प्रश्नामध्ये दिलेलं असतं त्यावेळेस तुम्हाला त्याचे जे हायपोथेसिस असतात ते चेक करण्याची आवश्यकता नसते. मीन्स व्हेन इट इज सेड दॅट some function satisfies the Rolle's theorem or Lagrange's mean value theorem, then it is not needed to check whether the conditions are satisfied. You just have to use the conclusion that there exists at least one C in the open interval A comma B satisfying the condition f dash of C. So you have to save the time and you have to save the space. या गोष्टी अतिशय महत्त्वाच्या असतात सीईटीच्या परीक्षेमध्ये. एन प्रकारे आपल्याला करेक्ट आन्सर मिळवणं हे आवश्यक असतं. हे लक्षात ठेवून आज आपण काही एक्झाम्पल्स सोडवणार आहोत. एक्झाम्पल 11 पाहतोय. त्यामध्ये इक्वेशन x log x is equals to 3 minus x has in open interval 1, 3. The options are related to the number of roots. तर रोल्स थिअरम मध्ये आपलं जे कन्क्लुजन असतं त्यामध्ये आपल्याला नंबर ऑफ रूट्स ऍटलिस्ट 1 रूट अशा प्रकारचा कन्क्लुजन असतो. याचा अर्थ हा प्रश्न रोल्स थिअरमशी निगडीत असण्याची शक्यता आहे. जर आपल्याला अशा प्रकारचं एक फंक्शन तयार करता आलं ज्याचा डेरिव्हेटिव्ह किंवा ज्याच्या डेरिव्हेटिव्ह मध्ये दिलेले इक्वेशन मधील टर्म्स असणार जर एखादं फंक्शन आपल्याला मिळवता आलं तर आपण त्यावरून या प्रश्नाचं उत्तर काढू शकतो. सो आपण या ठिकाणी असं एक फंक्शन तयार करण्याचा प्रयत्न केला पाहिजे ज्याचा डेरिव्हेटिव्ह या दिलेल्या इक्वेशन मध्ये आहे. तर सुरुवातीला आपण या दिलेल्या इक्वेशनला जर थोडंसं रिअरेंज केलं म्हणजेच उजव्या बाजूच्या टर्म जर डाव्या बाजूला घेतल्या तर मला मिळेल x-3 प्लस x log x इक्वल्स टू 0. पाहिलं पाहिजे की हा जो डावा बाजू आहे कुठल्या फंक्शनचा डेरिव्हेटिव्ह आहे का. सहजपणे कळते की हा डेरिव्हेटिव्ह नाहीये, कारण log x चा डेरिव्हेटिव्ह दुसऱ्या ठिकाणी 1/x असायला पाहिजे होता परंतु तो नाही. मग तशा प्रकारचं जर मला मिळवायचं असेल तर मी याच्या दोन्ही बाजूंना x ने जर भाग दिला तर मला मिळेल x-3 into 1/x plus log x equals to 0. आता सहज पाहता येईल की x-3 चा डेरिव्हेटिव्ह 1 जो की दुसऱ्या टर्म मध्ये आहे आणि log x चा डेरिव्हेटिव्ह 1/x हा पहिल्या टर्म मध्ये आहे. म्हणजेच हे जे फंक्शन आहे डाव्या बाजूचं ते log x into x-3 याचा डेरिव्हेटिव्ह आहे. म्हणजे मला अशा प्रकारचं एक फंक्शन मिळालेलं आहे ज्याचा डेरिव्हेटिव्ह आपल्याला दिलेल्या इक्वेशन मध्ये ऍडजस्ट करता येतो. सो आपण या ठिकाणी f of x बरोबर x-3 into log x जर घेतला सहजपणे पाहू शकतो की x-3 आणि log x हे कंटिन्युअस आणि डिफरन्शिएबल असल्यामुळे दिलेलं फंक्शन हे कंटिन्युअस डिफरन्शिएबल आहे. त्याचबरोबर f of 1 आणि f of 3 याच्या दोन्ही किमती जर आपण काढल्या तर त्याची येत आहे. याचाच अर्थ सर्व रोल्सच्या कंडिशन आणि जर रोल्सच्या सर्व कंडिशन या f of x ने सॅटिस्फाय केल्या तर आपल्याला माहिती आहे रोल्सचं कन्क्लुजन काय आहे की त्या ठिकाणी देयर एक्झिस्ट at least one x in the given interval, say 1, 3 in this case, such that f dash of x equals to 0. So that is by Rolle's theorem, f dash of x equals to 0 for at least one x. Now we know f dash of x, it is x-3 upon x plus log x. So equate this with 0. By Rolle's theorem, f dash of x is equals to 0. So if I equate it 0 and then multiply by x, I will get x-3 plus x log x equals to 0. Now take this x-3 to the right side and you will get x log x equals to 3 minus x, and by Rolle's it has at least one root in 1, 3. That's the answer. interval. If a plus b plus c equals to 0, then the equation 3ax square plus 2bx plus c equals to 0 has in open interval 0 comma 1. The options are related to the number of roots, and there is only one concept related to the number of roots in our syllabus, so that is related to the Rolle's theorem or the Lagrange's mean value. So in Rolle's theorem, we have the conclusion that there exists at least one x in the 0 comma 1 in the given interval satisfying f dash of x equals to 0. So if I can find a function whose derivative is the left hand side of this given equation, that is whose derivative is 3ax square plus 2bx plus c, means I need to find a function whose derivative is 3ax square plus 2bx plus c, and it can be obtained by integrating the left hand side. The integral of the left hand side is 3a into the integral of x square is x cubed by 3 plus 2b constant. The integral is x square by 2 plus c into x. So this is the integral of the left hand side. That means I am getting a function ax cube plus bx square plus cx whose derivative is nothing but the left hand side of the given equation. Now we can observe that this function f of x equals to ax cube plus bx square plus cx is a polynomial, and therefore it is continuous as well as differentiable in closed interval 0 comma 1. And the third condition of Rolle's is that f of 0 should be equal to f of 1. We find f of 0 by putting x equals to 0 in f of x, we will get 0, and f of 1 is nothing but a plus b plus c. If I put x equals to 1 in the given function, I will get f of 1 equals to a plus b plus c. And in the question it is given to be 0. It means f of 1 is also 0, f of 0 is 0. So all the conditions of Rolle's are satisfied, and therefore there exists at least one x belongs to the open interval 0 comma 1 satisfying f dash of x equals to 0. And f dash of x is nothing but the given LHS, that is 3ax square plus 2bx plus c equal to 0. So that is, there is at least one root in the given interval. So the answer is, correct answer is option A. Next example, if a0 upon n plus 1 plus a1 upon n plus a2 upon n minus 1 plus and so on up to an minus 1 upon 2 plus an equals to 0, then the equation a0 x raised to n plus a1 x raised to n minus 1 plus dot 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 an minus 1 into x plus an equal to 0 has in open interval 0 comma 1. Again, the options are related to the number of roots, means we have to use the Rolle's theorem. Means we have to find a function whose derivative is nothing but the LHS of the equation whose roots are required. That is, the function whose derivative is nothing but a0 x raised to n plus a1 x raised to n minus 1 plus and dot 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 an minus 1 x plus an. So I need to find a function. Derivative is the LHS. So which can be obtained by integrating. So integrate a0 constant x raised to n plus 1 upon n plus 1 plus a1 plus a1 into the integral of x raised to n minus 1 raise the power by 1 x raised to n upon n and plus and so on likewise. an minus 1, the integral of x is x square by 2, and finally plus the integral of an is an into x. So this is the function whose derivative is nothing but the LHS of that equation of roots are. So I will call this as a function, let f of x equals to this, and we can observe that it is a polynomial function, and so it is continuous and differentiable in the given interval. Also, you can find the values of f of 0 and f of 1. Means we have to verify whether this function f of x, which we have taken here, satisfies the conditions of Rolle's or not. That is, the continuity in closed interval 0 comma 1, the differentiability in open interval 0 comma 1, and finally f of 0 equals to f of 1. So we have to find the values of f of 0 and f of 1. If they are equal, then I can say that the conditions of Rolle's are satisfied. So see, f of 0, put x equals to 0 in the given function, in the supposed function, and it comes to be 0, and then find f of 1 putting x equals to 1 in that suppose function. We will get f of 1 is equals to a0 upon n plus 1 plus a1 upon n, and the terms of this kind plus and dot 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 an minus 1 upon 2, and finally there will be plus an. And in the question it is given that this value, that is which we have calculated as f of 1, is equals to 0. So we observe that f of 0 is 0, f of 1 is also 0. That means that the third condition of Rolle's theorem is also satisfied, and therefore by Rolle's theorem there exists x belongs to the open interval 0, 1 such that f dash of x exists at least one x is important, means the answer is at least one root. So it is option C. The correct answer is option C. Okay, we got the solution. 15th example, f of x is x into 2 minus x belongs to 0, 1, and we have to find the value of c by using the Lagrange's mean value theorem. One function is f of x is equals to, on multiplying 2x minus x square, its derivative is 2 minus 2x. By Lagrange's theorem, there exists at least one c belongs to open interval 0, 1 such that f dash of c is equals to f of b minus f of a upon b minus a. So in this case a is 0 and b is 1. So we can write f dash of c is equals to f of 1 minus f of 0 upon 1 minus 0. So f dash of x is 2 minus 2x, therefore f dash of c is nothing but 2 minus 2c. And the terms on the right side can be calculated by putting x equals to 1 and x equals to 0 in the given function. So f dash of c is nothing but 2 minus 2c, and I'll calculate the values of f of 1 and f of 0 on the right side by using the given function. So I get it, therefore 2 minus 2c is equals to f of 1 is nothing but 1 into bracket 2 minus 1, which is 1, minus f of 0 is 0 upon 1. So solving this, we get 2c equals to 1, and therefore c equals to 1 by 2 is the correct answer. Let's see the 15th example. F of x is equals to x into x minus 1 into x minus 2 in the closed interval 0, 1 by 2, and we have to find the value of c by using the Lagrange's mean value. On multiplying the terms on right side, you will get x cubed minus 3x squared plus 2x. It is a polynomial function, so continuous and differentiable in the closed interval 0, 1 by 2. Let us find its derivative because we need it in the conclusion. So f dash of x is nothing but 3x squared minus 6x plus 2. Now the conclusion of Lagrange's mean value theorem is known to us, that there exists at least one c in the open interval 0, 1 by 2, satisfying f dash of c is equals to f of b minus f of a upon b minus a. In this case, a is 0 and b is 1 by 2. So we can write f dash of c is equals to f of 1 by 2 minus f of 0 upon 1 by 2 minus 0. F of c is 3c square minus 6c plus 2, and the value of f of 1 by 2, which is 3 by 8, and the value of f of 0 is 0 upon the denominator as it is. So we will get a quadratic equation c, and which on solving will give me the values of c. So let us see the calculations. So if I put the values in this equation, f dash of c equals to f of 1 by 2 minus f of 0 upon 1 by 2 minus 0, we will get this thing. 3c square minus 6c plus 2 equals to 3 by 8 minus 0 upon 1 by 2. Solving, we get quadratic. This kind, 12c square minus 24c plus 5 equals to 0. This quadratic equation, by using the formula, we will get the two values of c as c is equals to 24 plus minus root 336 upon 24. Separating, you will get the two values, 1 plus root 21 upon 6 and another is 1 minus root 21 upon 6. Clearly 1 plus root 21 by 6 will not belong to the open interval 0, 1 by 2. It means that 1 minus root 21 by 6 must be in the interval, because 1 minus something is there, and it is not our job to check whether it is in the interval or not in the examination, because there is only one option of that kind, and 1 plus root 21 by 6 is not possible. So the answer is 1 minus root 21. Similar example as above, a function f of x is x plus 1 by x and x belongs to 1, 3. We have to find the value of c using the Lagrange's mean value theorem. So again, we know that there exists at least one c belongs to open interval 1, 3 satisfying the condition f dash of c is equals to f of b minus f of a upon b minus a. So in this case, a is 1 and b is 3. Therefore, we will get f dash of c is equals to f of 3 minus f of 1 upon 3 minus 1. So we will calculate the values of f of 1 and f of 3 from the given function. F of 3 will be 3 plus 1 by 3 and f of 1 will be 1 plus 1 by 1 means 1 plus 1 divided by 3 minus 1, and f dash of c can be obtained by using the formula for f dash of x, which is 1 minus 1 by x square. On differentiation I will get 1 minus 1 by x square as the derivative of f of x. So if I put x equals to c, I will get f dash of c, which is 1 minus 1 by c square. So solving the equation, you will get 2 by 3 is equals to 1 minus 1 by c square. Take that 1 by c square to the left side and 2 by 3 to the right side. We will get 1 by c square equals to 1 by 3, and therefore c square equals to 3. Therefore c is equals to plus minus root 3. But minus root 3 doesn't lie, or it doesn't belong to our interval, and therefore 3 is the correct answer. That is option B. Let us see the 70th example. F of x is x into x plus 4 whole square and x belongs to the closed interval 0, 4. We have to find the value of c by using the Lagrange's theorem. The same question again by Lagrange's mean value theorem. If the conditions are satisfied, already the conditions are satisfied because it is a polynomial, and therefore by Lagrange's mean value theorem, there exists at least one c belongs to the open interval 0, 4 satisfying the condition f dash of c is equals to f of 4 minus f of 0 upon 4 minus 0. So by using the formula for f dash of x, we can find f dash of c, which is 3c square plus 16x plus 16. The values of f of 4 and f of 0 can be obtained using the given function. F of 4 is nothing but that 4 cube plus 8 into 4 square plus 16 into 4, which is nothing but 64 plus 128 plus 64 divided by 4, and f of 0 is 0, and the f dash of c is nothing but 3c square plus 16c plus 16. So solving, we will get the equation, a quadratic equation. On the left side we will get 64 is equals to 3c square plus 16c plus 16, and rearranging the terms we will get 3c square plus 16c minus 48 equals to 0. By using the formula for quadratic equation, we will get the two values of c as minus 16 plus minus 8 root 13 upon 6. But minus 16 minus 8 root 13 upon 6 is a negative quantity, and so it doesn't belong to the given interval, and therefore the remaining must be the answer. That is minus 16 plus 8 root 13 upon 6 must be the answer. In CET examinations, we need not to check whether it belongs to the given interval or not, because definitely minus 16 minus 8 root 13 upon 6 is not there, so the remaining must be there. So the answer is option C. For example, we have given a function f of x is equals to x minus 1 whole raised to 2 by 3, and we have to find the interval in which the Lagrange's mean value theorem is applicable. So the Lagrange's mean value theorem is applicable if the given function is continuous on the closed interval and it is differentiable on the open interval. So clearly f of x is equals to fx minus 1 whole raised to 2 by 3. It's continuous for all values of x because every real number has at least one real cube root. So it is a real function and it is continuous for all x. Let us find the derivative of given function, which is f dash of x is equals to, take that power in multiplication, 2 by 3 into x minus 1 whole raised to 2 by 3 minus 1, which is minus 1 by 3. So using the laws of indices, it can be written as 2 upon 3 into x minus 1 whole raised to 1 by 3. Clearly at x equals to 1 the denominator becomes 0. It means that at x equals to 1 the derivative doesn't exist. It means that the value x equals to 1 should not be there in the interval because at that point the function will not be differentiable. In option B, C and D there is 1, and so B, C and D are not the answers of this question, and therefore A must be the correct answer because 1 is not there. Okay, so correct answer is option A. The 19th example, it is given that f of x satisfies the conditions of Lagrange's mean value theorem in closed interval 0, 2, and f of 0 equals to 0 and f dash of x is less than or equals to 1 by 2 for all x in closed interval 0, 2, then we have to find the range of f of x. So as the Lagrange's mean value theorem is applicable in closed interval 0, 2, it means that by using the conclusion of Lagrange's theorem that there exists at least one c in the closed interval 0, 2, or one can say there exists at least one x in the closed interval 0, 2 such that f dash of x is equals to f of 2 minus f of 0 upon 2 minus 0. As the rules is applicable for it must be applicable for its subintervals. That is, for any x belongs to closed interval 0, 2, the Lagrange's theorem must be applicable for the interval 0, x. That means I can write there exists that same x for which f dash of x is equals to f of x minus f of 0 upon x. But in the question we have given f of 0 is 0. So I will get f of x upon x equals to f dash of x, and therefore f of x is equals to x into f dash of x. Isn't that? Now we have given that f dash of x is less than or equals to 1 by 2. That means the right hand side here is less than or equals to x into 1 by 2 because f dash of x is less than or equals to 1 by 2. That means that f of x is less than or equals to x by 2, but the maximum value of x is 2 in the given interval, and therefore this x by 2 must be less than or equals to 2 by 2, which is 1, and therefore f of x is less than or equals to 1 is the correct answer given in option B. Okay. See now question number 20. F of x is differentiable in closed interval 2, 5, where f of 2 is 1 by 5, f of 5 is 1 by 2, and we have to find, it is given that there exists c in the open interval 2, 5 for which f dash of c equals to. Means we have to find the value of f dash of c by using the Lagrange's mean value, because f of 2 and f of 5 are not same. These rules cannot be used. So Lagrange's mean value theorem, there exists c, at least one c, such that f dash of c is equals to f of 5 minus f of 2 upon 5 minus 2. So in the question the values of f of 2 and f of 5 are given. So substituting the value of f of 5, which is 1 by 2 minus then f 1 by 5 divided by 5 minus 2 is 3. after solving we will get the value 1 by 10, which is option 21. We have to find value of c by using the Lagrange's mean value theorem for the function f of x is equals to log of sin x in the closed interval pi by 6 comma 5 pi by 6. So by Lagrange's mean value theorem, we know that there exists at least one c in the given interval satisfying the condition f dash of c is equals to f of b minus f of a upon b minus a. So in this case, a is nothing but pi by 6 and b is nothing but 5 pi by 6, and we are interested in the value of c using the Lagrange's mean value. So we need to find the values of f of 5 pi by 6 and f of pi by 6. The function is f of x is equals to log of sin x. So let us find the values, that is f of 5 pi by 6 and f of pi by 6. For that you should know the value of sin 5 pi by 6 and sin pi by 6. Sin 5 pi by 6 means sin 150, which is nothing but sin 90 plus 60, which is cos 60 and 1 by 2, and sin pi by 6 is also 1 by 2. It means that the value of f of 5 pi by 6, which is nothing but log of sin 5 pi by 6, and it is equals to log of 1 by 2. And the value of f of pi by 6 is also log of 1 by 2. It means that f of 5 pi by 6 and f of pi by 6 are same, and therefore the numerator is 0. That means f dash of c equals to 0. But we know the derivative of f of x, that is the derivative of log of sin x, is 1 by sin into cos, means cot x. So f dash of c will become cot c equals to 0. We know that cot c is 0 at c is equals to pi by 2 in the given interval, and therefore the correct answer is option B. Okay. For the function f of x equals to e raised to x, a equals to 0 and b equals to 1 are given, and we have to find the value of c by using the Lagrange's mean value theorem. We know the Lagrange's mean value theorem is that there exists at least one c in the given interval satisfying f dash of c equals to f of b minus f of a upon b minus a. F dash of x is nothing but e raised to x, and so f dash of c will be e raised to c. F of b means f of 1, which is e raised to 1, minus f of a means f of 0, which is e raised to 0, which is 1, divided by b minus a means 1 minus 0. So we have e raised to c is equals to e minus 1, and we need to find the value of c. So taking log on both sides, the left hand side is log of e raised to c means c, and the right hand side is log of e minus 1, and therefore the answer is c is equals to log of e minus 1, and it is option B. One more question from Rolle's theorem, Rolle's mean value theorem. F of x is given as x into x plus 3 into e raised to minus x by 2, and it satisfies all the conditions of Rolle's theorem in closed interval minus 3 comma 0, and we have to find the value of c. We know the Rolle's theorem that there exists at least one c in the open interval satisfying f dash of c equals to 0. So first of all we should find the derivative of the given function. The given function is nothing but, on multiplying the first two terms we will get x square plus 3x into e raised to minus x by 2 as it is. This can be differentiated by using the derivative of product, that is f dash of x is equals to, the first function is x square plus 3x into the derivative of second. First function x square plus 3x as it is into the derivative of e raised to minus x by 2 is e raised to minus x by 2 into minus 1 by 2. Okay, plus the second function as it is means e raised to minus x by 2 as it is into the derivative of first means the derivative of x square plus 3x, which is nothing but 2x plus 3. Okay, so I'm taking that e raised to minus x by 2 as a common. Inside the bracket we will get 2x plus 3, then this minus x square plus 3x upon 2. I need to find the value of x for which f dash of x is 0. This is your f dash of x. It is e raised to minus x by 2 inside the bracket 2x plus 3 minus x square plus 3x upon 2 is your f dash of x. So solving the terms inside the bracket, we will get e raised to minus x by 2 upon 2 into 6 minus x square plus x. Clearly e raised to minus x by 2 is non-zero. That means for f dash of x to be equal to 0, the bracketed term must be 0. It can be factorized. That factors of 6 minus x square plus x are 3 minus x into 2 plus x. So this f dash of x, which is nothing but e raised to minus x by 2 upon 2 into 3 minus x into 2 plus x, will be 0 at x equals to 3 or x equals to minus. But x equals to 3 doesn't belong to the given interval, and therefore the answer is x equals to minus 2. Means c equals to minus 2. I'm saying x, there exists at least one c, one may say at least one x. So c is equals to minus 2 is the correct answer, which is given in option C. The last question from Rolle's theorem. It is given that function f of x satisfies the conditions of Rolle's theorem in close the interval 1 comma 2, and we have to find the definite integral from 1 to 2 f dash of x dx. We know that integral of f dash of x dx is nothing but x plus some constant may be there, but as we have to find the definite integral is not needed. So the definite integral 1 to 2 f dash of x dx is nothing but the difference of f of x between the limits 1 to 2. That is, it is equals to f of 2 minus f of 1. But as the Rolle's theorem is satisfied, the conditions of Rolle's are satisfied. The third condition says that f of 1 is equals to f of 2. That means the difference f of 2 minus f of 1 is equals to 0, and so